Okay, welcome, honors pre-calculus students. This is a second part of the binomial theorem. So, in the first part, we introduced what is a binomial theorem, and you must know the general term. What is the general term? So, this is the, let me again explain. This is the general term, which is very, very helpful to do the examples. And if you just know how to use this that will help you to do a little bit complicated problems as well. So let's take a look at this page. And here we are going to do slightly different types of problem, which says find particular term. So for example, a third term, which means if I expand this, what will be my third term? This is the 20th term. Now, it's not very practical to find all the term and then you select particular term. There is always a more efficient way to find particular term. So I'm going to write the binomial theorem one more time here, which is n choose r, a and b. B always have a power of r and a is always n minus r. So this is your general term, and that will help you to understand how to find particular term. So if you need a third term, so what will be the value of n? First of all, n is a 6. But then what is r? Because here you don't know what's the coefficient. So what will be the value of r? So for that part, I would like to point out something is you always start from 0. Know that always start from 0. So which means always, for even if a Pascal's triangle, first is always the 0 power. So in this case, if you start with a 0, so third term would be, what will be the value of r? Third term means r is a 2 because you start with a 0, 1, 2. So third term is a 2. In this case, 20th term, so that means r is 19. Think of that way, one less. N is 25. N is 25. R is, always you start from 0. So R is the value one less from here. So let's set it up. 6, choose 2. A, A is A. B is negative 2 root 3. You must include the negative sign along with the number. And what will be the power? Now, in this case, we are working backward. Once you figure out 2, that 2 goes here. These two number add up to 6, so this power has to be 4. So slightly different type of problem here again. One more time, you are given a third term, so that means this is a 2. If that's a 2, this number goes there. That's a 2. 2 plus 4 is 6, and then you simplify further. So let's check it out. What is 6 choose 2? 6 factorial, 2 factorial, 6 minus 2, 4 factorial. A to the 4, negative number to the second power. So sometimes many students are struggling with the radical and the power. So basically you write 2 times 2 root 3, 3 times 2 root 3, and 2 negative makes it positive. So here we have to find the entire term. So you need every single thing. So first of all, I'm going to write down a to the 4 so that we can simplify the factorials and the coefficients. So 6 factorial divided by 4 factorial, which means you have a 5 times 6, 4, 4 get cancelled. You have a 2 factorial is a 2, 2 times 2 is a 4, and root 3 times root 3 is 3. And this would be, you are expected to simplify this number. 5 times 4 is 20. 20 divided by 2 is 10. 6 times 3, 18. And 188 to the 4. This is my entire answer, which means you need all of them. That's my third term. So let's practice some more for this kind of problem. Like previously I said that if it is a 20th term, that means R is 19. You always start from 0. Now here we have a pretty high power number, and you are not expected to simplify this, but I still need to see this setup. So 25, this is 2n and negative 3m. Okay, so like I said, 20th term, so one less is 19, which means that number will be 19. Those two always match. Now, what would be this number which you add up to make it to 25? So 19 plus 6 is 25. Now, you have to show me this setup, even if it's a very high numbers. So let's simplify. 25 factorial, 19 factorial, difference between two is 6 factorial, 2 to the 6, n to the 6, negative 3 to the 19. I'm leaving it as it is, negative number, and m to the 19. So yes, this is going to be a very big number, but let's see what is there. 25 factorial over 19 factorial, which will give you, um, you can use a calculator to get these numbers, but let's leave it as it is. We will accept this if you, because of the calculator will also run out of memory. 2 to the 6, negative number to the 19th power is negative. So 3 to the 19th and n to the 6, m to the 19th. We will accept this answer. So we are making sure that you have a negative sign and these numbers are correct and every single thing has to be correct. So 20th power means, the 20th term means r is 19. Now we have another very interesting problem. So let's check it out. Constant term. Find the expansion of the 10th power constant term. What is the meaning of constant term? First of all, let's check it out, that one. Constant term means exponent has to be 0. That will give me number 1. For example, so I need this term which has exponent 0. Fortunately, you have a 2 and negative 2 and 10. So let's set it up first of all. 10 x to the 2 x to the negative 2. Negative, my bad, negative. Okay, so what would be basically, what would give you 0 power? What are these two numbers? You add up to give you 10. And this 2 and negative 2, so that if you simplify, which give you 0. So this case is a little bit easier, and of course we would ask you not impossible question. We will always ask you where answer is possible. So obviously this two number has to be 5 and 5. That means 5 plus 5 is a 10. X to the 10 if you simplify, and x to the negative 10, positive 10, negative 10 makes it 0. And this is a 5. So let's simplify one more time. 10 factorial, 5 factorial, 5 factorial. I'm writing still x to the 10. Negative number to the, this would be negative sign, x to the negative 10. And negative 10, positive 10, you add the power, that will be 0. And coefficient is negative sign 10 factorial divided by 5 factorial times 5 factorial. And yes, this is a doable problem. I want you to understand how to simplify. So 10 factorial means one of the 5 factorial will be gone, and I will have 10 times 9 times 8 times 7 times 6. And one of the 5 factorial is gone. And this would be 5 times 4 times 3 times 2 times 1. So let's check it out. What would be? Can we say 4 times 2 is 8? And 3 times 2 is a 6. 5 times 2 is a 10. So 2 times 2 times 7 times 9, and that number is negative 252. That will be the answer. So no constant term means exponent is a 0. There are some practice problem in the worksheet you will have to do tomorrow. Okay, so another interesting. What's the value of this I? So and you have to add. So you have to expand and you have to add. So let's do it. 1 plus I to the sixth power. Okay, so 6 power means 7 terms, and you can check the coefficients from the Pascal's triangle. The coefficients are going to be 1, 15, no, not 15, sorry. Coefficients are going to be 1, 6, 15, 20, 15, 6, and 1. So 1, 2, 3, 4, 5, 6, 7. Those are the coefficients. So this is pretty interesting problem. So let's use this coefficient and expand. So 1, 6i, 15i square, because all the powers of 1 will be 1, so I'm skipping that. 20i to the third, 15i to the 4. Remember, powers of b goes up. 6i to the 5 and I to the 6. So powers of 1 going down, but the 1 is 1. Powers of I going up. Okay, so now 1 minus I to the 6, which is 1. Negative, so that's a negative 6i. Third term is positive, because I to the negative I to the square is positive I square. This would be negative, third power, negative. Fourth power, positive again. Fifth power, negative. And the sixth power, positive. So what is I actually? Let's check. You should know that I is square root negative 1. I square is negative 1. I to the 4 is positive 1. I to the 6 is back to negative 1. Okay, so now we have to add this. This is a very interesting problem. You are adding everything. So 1 plus 1 is 2. 6i gone. 30i square. This is gone. 30i to the 4 and 2i to the 6. So 2. What is I square? I square is negative 1. So 30 times negative 1. What is I to the 4? I to the 4 is a 1. And I to the 6 is negative 1. So 30, 30 get cancelled out. 2, 2 get cancelled out. Answer is a 0. Pretty interesting problem. We wanted you to, two purpose here. We wanted you to understand the powers of I. I is a imaginary number, and this is a recall your memory from previous class, and how to expand and how to add. So very interesting problem. Now let's take a look at this. Last is a challenge question. I would help you to set up, and simplifying involves a lot of algebra. So well, let's understand the question. What's the value of R if the coefficient of these two are equal in this setup? So first of all, let's set it up. I want two coefficients are equal. So power is 19, 3x and 2. 19, 3x and 2. Now we don't have a power. This is talking about power of R and R plus 1. So we can do so many different ways. Power of R. So this is, let's say, I put it as a R. Let me bring my work here so that it's much easier to explain. Okay, so power of R. Apologize. I just want you to reveal the work so that I can explain step by step. Have patience with me. Okay, so let's talk about here. Setup. So power of R means this is, power of R means if this is a R, this is R plus 1. Now remember the total is 19. So this both sum has to be 19. So power of 2 is 19 minus R. X to the R, I'm just looking at this, setting up x to the R plus 1. How do you get this number? Because the both of them has to be sum has to be 19. So this is 19 minus R. this number is the same as that. Sum of these two has to be 19. So this is r plus 1. That has to be 18 minus r. And this has to be same as that. Now the next step is simplifying. So I'm just using formula 19 factorial 19 minus r factorial, and formula says this is a difference of these two. So 19 minus r factorial, 3 to the r x to the r, but this says coefficient, we only have to compare. So we just take out the x to the r. We don't need x to the r because we are looking at only coefficient. 2 to the 19 minus r. This is 3 to the r plus 1, 2 to the 18 minus r, and again using the formula. And all the rest of the work is nothing but simplifying with a factorial and cross multiplication. R factorial 1 plus r factorial, let's go on the side, divide by I. R factorial is 1 plus r. 19 minus r and 18 minus r, left is 19 minus r. And then what I did is I distribute and simplified. R is 11. We don't expect that the student can do this in a limited time during the assessment. Again, this is a challenge question, and it's sometimes it's interesting to see what if. So if you are not understanding this, don't worry. You must know every single thing up to example 8. So I'm going over one more time on these 3 pages. On this page, we introduce the binomial theorem and expansion. And the next page was how to find the coefficient, particular coefficient. I'm going over a summary, every single type of question. This is a coefficient, how to find. Then how to find every single term, which is pretty like grinding it out. Powers of A going down, powers of B going up, and get the coefficient. The third type of problem we did is how to find particular term, which you must know the general term and then set it up. And then we did a constant term, which is also very interesting. Constant term means exponent is a 0. And example 9 includes some imaginary numbers. Don't worry about example 10. And now you should be able to do this homework. Homework is pretty straightforward, not very complicated. You can see this kind of questions we asked. We did some examples in the classroom. And same kind, radicals, you can rewrite as x to the half, y to the half. Negative exponents, be very careful. You must know how to simplify them as well. And check the class notes and the answer key of the textbook solution in the textbook solution folder. Thank you so much.